Hello everyone and welcome back to our video, and in today's video we'll be talking about partial derivatives with respect to functions with three independent variables. The first example here is given a function of f of x, y, and z equals to x squared, y cubed, z to the fourth. Find f sub x, f sub y, and f sub z. So in this function we have here three independent variables, and those are x, y, and z. And notice that in the expression it is a combination of x squared, y cubed, and z to the fourth, but it is considered as a single expression because they are not separated by plus and minus sign, so it means we have only one term. So first job that we'll do is to find f sub x, and when we are differentiating with respect to x, we are holding variable y and variable z as constant. So we'll just write here y cubed and z to the fourth, and then we'll find the partial of a function with respect to x. So what is the partial derivative with respect to x of x squared? The answer will be y cubed z to the fourth times the partial of x squared with respect to x, and that is 2x. So simplifying, we'll have 2x y cubed z raised to the fourth. So this is now the answer for f sub x. Now for f sub y, when we are differentiating with respect to y, it means we will be holding x and z as constant. So in the given expression, we'll write just here x squared and z to the fourth, and then we'll multiply this expression by the partial derivative with respect to y of y raised to 3. And the answer is x squared z to the fourth power times the derivative with respect to y of y cubed, that is 3y squared. Okay, so finally the answer will be 3x squared y squared z to the fourth. This is now our value for f sub y. For f sub z, we'll follow the same, but this time we are differentiating with respect to z. That's why we'll hold x and y as constant. So we'll just write here x squared y cubed, and then we'll find the partial with respect to z of z raised to 4. The answer will be x squared y cubed, and the partial of z to the 4th power with respect to z, that is equal to 4z cubed. Finally, by simplification, the answer will be 4x squared y cubed z cubed. So this is the value of f sub x, this is f sub y, and this is f sub z. Here in the next example, we have function w is equal to x to the 5th power, y squared, and z to the 4th power. The requirement is the partial of w with respect to x, the partial of w with respect to y, and the partial derivative of our function w with respect to z. Have first the partial of our function w with respect to x. So when we are differentiating with respect to x, then we'll be holding y squared and z to the 4th as constant. So we'll write here y squared z to the 4th, and then we'll find the partial with respect to x of our variable x raised to the 5th power. The answer will be y squared z to the 4th power times the partial of x to the 5th with respect to x, that is obviously 5x raised to the 4th power. And by simplification, we'll have here 5x raised to the 4th power y squared z to the 4th power. This is now the value of our partial of w with respect to x. Now we'll have the partial of our function w with respect to y. When we are differentiating with respect to y, we're holding the variable x and z as constant. So we'll just write here x squared and then z to the 4th power. and then we'll get the partial with respect to y of y squared. Okay, so this is equal to x squared z to the fourth power times the derivative of y squared with respect to y, which is 2y, and then we'll simplify. This will become 2x squared y z to the fourth power. That's easy. And the last one here is the partial of our function w with respect to z. And this time, if this is with respect to z, we'll be holding variable x and y as constant. So I'll just write here x to the fifth power y squared, and then we'll multiply this with the partial derivative with respect to z of an expression with variable z, and that is z to the fourth power. The answer will be x to the fifth y squared times the partial derivative of z to the fourth with respect to z, which is 4z cubed. So the answer will be 4x to the fifth power y squared z raised to the third power. This is now the partial derivative of w with respect to z, and this is the partial derivative with respect to y, and this is the partial derivative with respect to x. That is all about example number 2. Here in example number 3, this is somewhat different from the previous one, because here in the problem we have the second instruction: further evaluate f sub y at point 1, 2, and 3. So before we can evaluate f sub y at point p 1, 2, and 3, we'll find first f sub x, f sub y, and f sub z. Now first job here is to find the value of f sub x. So f sub x is equal to, we are differentiating with respect to x, and in the first term we have variable x and y, so we'll held y squared as a constant. We'll have the partial with respect to x of 4x times y squared, plus in the second expression we have z and x, so we have 3z, and then the partial with respect to x of x cubed. And in the third term we have 5yz to the fourth. There's no variable x here, so in other words, we'll be getting the partial derivative of an expression without x variable. So what's the partial with respect to x of 5yz to the fourth power? Now, simplifying, the partial of 4x with respect to x is 4, and then we'll write the constant y squared, plus the partial derivative of x cubed with respect to x is 3x squared, and then the constant 3z, plus this is 0 because the whole term here is an expression without x variable, so that will become a constant, and the derivative of the constant is 0. Simplifying, this will be 4y squared, and then we have 9x squared z. That will be the final answer for f sub x. For f sub y, we will have 4x, and then the partial with respect to y of y squared, plus the next expression, there is no y variable here, so in other words, the derivative of that will become 0. I will not write anymore the partial here, because we know that the second expression is without variable y, so that will become a constant, and the derivative of the constant will become 0. Okay, now in the third expression we have 5yz to the fourth, so we have z to the fourth as the constant, and we'll get the partial with respect to y of 5y. So this will become the partial with respect to y of y squared, that will be 4x times 2y, okay, plus z to the fourth times the partial of 5y with respect to y is 5. Simplifying, this will become 4 and 2, that will become 8xy plus 5z to the fourth power. So this is now the partial derivative of the given function with respect to y. Okay. Finally, for f of z, The first expression is an expression without z variable, so that will become a constant. So in other words, that will become 0. Plus, the second expression, we have 3zx cubed. So, z variable, that was the partial of 3z with respect to z. That will become 3x cubed. X cubed is the constant, so I will just write here x cubed. Plus, the last term, we have z to the fourth and 5y. So this will become 5y times the partial of z to the fourth, which is 4z cubed. So finally, we will have 3x cubed plus 20y z cubed. This will be our partial derivative with respect to. In the last requirement, we are required to evaluate f sub y at point 1, 2, 3. So, f sub y at point 1, 2, 3, we'll be using this value here of f sub y. So, we'll have 8xy plus 5z to the fourth. And we will evaluate this one by the point 1, 2, and 3. So what will you do? You will just substitute 1, 2, 3 to x, y, and z. This will become 8 times the value of x, there is 1. The value of y is 2. Plus 5 times the value of z is 3. And we will raise that to the fourth power. And then we will simplify. That will become 8 times 1 times 2. That will become 16. Plus 3 raised to the fourth power times 5. You have there the calculator, you can solve that, so that will become 405. And finally, the answer will be 421. So this is now the value when we evaluate f sub y at point 1, 2, and 3. That is the first part of our video, and I'm hoping that you will watch the second part of the video which will be coming soon. Thank you very much.